Okay. So in this case, the thing we don't know, by the way, this M1V1 is equal to M2V2 is really helpful if you need to make up a dilution too. Okay, in this case, we make up a dilution, we want to know the molarity. We solve for M2, which is the molar concentration of the diluted sample, and that's equal to M1V1 divided by V2. So for instance, for your first dilution, it would be the molarity of the stock, 0.392, times the volume of the stock, 2.00 milliliters. I would still use units, so it would be 0.392 molar times 2.00 milliliters divided by 10.00 milliliters, because that's the volume of your diluted solution. Okay, I'm going to add that. So for the first one, it is 0.392 molar times 2.00 milliliters. And notice that, we're using units just like we do in Chem 1. Okay, and the units that cancel need to cancel, actually. The diluted volume is 10.00 milliliters. So, but again, like you did in your reports before, you have to show all of your work. You get the same answer either way. All right. So then you're ready to pull up Logger Pro, okay, and basically do this. Pull up Logger Pro and do this. I thought if it's okay with you, I'm going to remind you a few things about Logger Pro. Okay. But I'm going to finish this thought. So basically, use Logger Pro, prepare a calibration curve, and actually there's only 2 calculations, aren't there? Mm-hmm. Okay. and pick off your unknown. So here is kind of what this looks like. This is actually what I drew on the absorbance along the y-axis, concentration, molar concentration of nickel 2 sulfate along the x-axis. We talked about how straight your line is. That can be gauged by your correlation coefficient, which if it has a positive slope, the closer it is to 1, the better. And then here is your maximum. That last point is going to be your sample, your 5th sample, which is 10 mL of your stock solution. And we have water down there. And then just to kind of finish that thought, here I have your unknown. Say this was the absorbance. You come over where it intersects your calibration curve, okay, and pick off the unknown of your absorbance. So I need to see that. So you need to see the graph and the ordered pairs. Okay. Any questions about that? So here is Logger Pro. And I've already gone ahead and done a little bit with Logger Pro before y'all came in. Notice I have 2 columns over there. I have my water is my first point. Seems like I'm missing a point, aren't I? Just can't get that right this year. Okay, but there'll be actually one more diluted point in there between 1 and 5. Now, one of the things I wanted to remind you, notice that I put down molarity, and these are I just made these up, so don't go with these. But I put a molarity of, for instance, number 4 as 0.33. And what if I wanted 3 significant figures? What if the molarity I calculate is 0.330 moles per liter of nickel 2 sulfate? Now, remember how you do that is you can right-click on the molarity, the column header, and it would say column options. I pick column options of molarity, and this is where if I go under options, that's, by the way, that same right-click options was where I gave it a title. Over here where it says precision, if I click on significant figures, and if I want to go with 3 significant figures, then it will do what I need it to do. Okay? So let's go ahead and throw in some absorptions here. Now these are just totally made up. What would the absorbance of water be? 0. Very good. Well, we'll start with that. My keyboard doesn't work. Did it go? There it goes. Let's see. Just making things up as we go. How about, what was the absorbance? Was it like 0.14? What was that one sample? 0.168. Okay.
Remember 5?
Uh-huh. that's why it thanks. I was like, why aren't you taking that? Yep, that must be. My keyboard died, so I'm. Thanks, Marie. Okay, so let's go ahead and, what'd you say, Hunter?
0.168.
168. We'll go ahead and throw that in there just for kicks. I have no idea. So this one above it would be less, right? So we'll kind of split the difference, 0.08. Oh my goodness. And again, it's kind of, we might have to go back and give it more digits. Let's add 0.08 to that. Let's go ahead and do that. And then, like that. Wow. And I'm not liking this. So see this down here? Okay. Like, oh no. So let's go ahead and play around with our scaling here. So while I'm over here, I'm going to do a right click. And I'm going to go to graph options. Or there's an auto scale. Should I try auto scale? Let's just try auto scale. I'm feeling much better about that. Okay. So I see a little bit of scatter, which you may or may not have. So remember how this works is I'm going to go ahead and draw my line in. And let's see, I think I'm going to go to Analyze. And I'm going to go to Linear Fit. Not bad. Okay, there's my black line. Notice my correlation coefficient is, it's not 1, it's 0.9692, which I think is kind. All right. So then we're ready to, you're very close. Okay. We need to go ahead and let's say that you got an unknown absorbance. Let's say we got 0.200, just because it's easier. 0.200. So remember, there's a few ways you can do this. Up under, I think it's Analyze. There is it interpolate? Okay. Now what interpolate means is basically to interpret your calibration curve. So notice that I can put another box up there, and actually this is a way that if you know how to print, if you can figure out how to print it like this, I think you can. I think I played around with this before. I need to find an absorbance of, what did I say, 0.200? So I'm skipping along. Notice it's skipping along the curve for me. So right here-ish, steady hand, somewhere in there. 0.20091. Okay. So that would say, what's my unknown then, molarity? 2.7. Yeah, 0.277 probably moles per liter. So that's kind of how that goes. Let me know if you have any questions how to print this, but I'm pretty sure if you're careful, I think the way I figured it is if I take my interpolation thing and kind of go off the graph and kind of bring it over, I can actually print that graph. So if you're kind of careful how you zoom up and kind of go over. That's how I kind of tricked it. So don't forget, and you do it by doing a right click on your graph, and don't forget to give it a title. So basically you need 3 things still on this. You need a title for your graph, and you need to, well, it's already labeled this, so that's pretty good. I guess you don't need to label those because they came with the, so just a title and a graph. Good titles are usually Y versus X. So a good title for this would be absorbance versus molarity, nickel 2-sulfate. Not copper 2-sulfate. Okay? So yeah, excellent. So I guess I'll see you on the other side. And yeah, we do need to wear goggles.